Okay, so we will discuss the bivariate data analysis. And bivariate means we have to take two variables and do some analysis. And the popular bivariate data analysis are the cross tabulation, scatter diagram, simple correlation analysis, and simple regression analysis. And in a cross tabulation, what we will do, we provide the joint frequency distribution of two variables in a bivariate data analysis. So in a cross tabulation, there is a possibility of more than two variables, but because here we are discussing the bivariate data analysis, so we will take only two variables. I will show you a cross tabulation, then it will be clear to you what is a cross tabulation. Okay, I am going to share cross tabulation with you. Can you see the cross tabulation, gender, age cross tabulation? Yes?
Yes, sir.
Yes, sir.
Okay, so you look at here, this is the cross tabulation for gender and age. Now here we have two variables. One variable is age and the other variable is gender. So in the gender we have male and female, and in the age we have different groups. So this is called cross tabulation. So this means in the age group 31 to 35, there are how many females? Can anyone answer? There are how many females in the age group 31 to 35?
10, sir.
10, sir. 10.
10.
Yes, there are 10 female. Okay, so then there are how many males in the age group 26 to 30?
8.
8.
Yes, yes. So it means here you see we have male. So in this group we have 2 male, then we have 8 male, then 28, and then 2. So there are total 40 males. There are total 40 females, and the total data is 80. And then in this group there are 2 female only. There are no male. Here there are 2 male and no female. Like this. So this is a cross tabulation. So it's very simple. Okay. Now again I will go to the lecture slide. Can you see the PowerPoint slide?
No, sir.
Can you see?
Yes, sir.
Okay.
Yes, sir.
So then
Yes, sir.
the second bivariate data analysis is the scatter diagram. So I hope you learn scatter diagram in your statistics course. What we do in a scatter diagram, we take two variables and we plot these two variables on a graph, and we will not join the paired values. Okay, so we just have the paired values of two variables. Yes.
सर ये क्रॉस टेबुलेशन जो आपने भी दिखाया है ग्राफ सर ये जस्ट डाटा को शो कर रहा है सर, इसमें हमारी फाइंडिंग्स क्या होंगी सर?
Findings were clear, no? Just the question which I asked for the findings, no? Okay.
So just
You are representing the data, no? Through cross tabulation.
okay.
That is the representation of data, just like we represent data through bar diagram. Okay? And then looking to that, we will have some findings. No? So in a scatter diagram, okay, we plot the paired values of two variables on a graph paper without joining them. So we will not join these. Okay. And let me show you the scatter plot. Here, you can see here, okay. So this is the scatter plot, no? So here the paired values of x and y are plotted and they are not joined. This is a scatter plot. Why we have to draw the scatter plots? So this is normally we want to know the nature of relationship between two variables, okay. So we want to know about the correlation, okay. So correlation is basically the degree of relationship existing between two variables, okay. So the degree of relationship existing between two variable if it is a bivariate data analysis. And correlation we study through scatter diagram. So we have to plot a scatter diagram, or we study the correlation through correlation coefficient. And the range of correlation coefficient is from -1 to +1. So if the value is -1, this means there is a perfect negative correlation. And if the value is +1, this means a perfect positive correlation. And if the value of correlation coefficient is 0, this means there is no correlation. Let's look at here. So here through scatter diagram we want to know about the nature and extent of correlation. You can see here all points are, if I draw a straight line, so all point would be on the linear positively sloped straight line. So this type of scatter diagram shows a perfect positive correlation, and this type of scatter diagram shows a perfect negative correlation, because if I plot a linear line here, so all points would be on that negatively sloped linear line. Here we have a close positive correlation. Here we have close negative correlation, okay. So here there is a very weak relationship. Here also very weak. We cannot say anything about the correlation. Here we have weak positive, here we have weak negative. So let me show you the values. These are the range for the values of correlation coefficient, okay. You can see here, if it is -1, so then perfect negative correlation, and then from minus 0.8, between -0.8 and -1 there is high negative correlation, then we have moderate, then we have low and very low, okay, and then negligible. And this side we have positive, so we have negligible positive relationship, very low positive relationship, low and moderate and high, and this is the perfect positive correlation. So suppose if I get a value of correlation coefficient 0.98, then it means there is a very strong positive correlation. And if I get minus 0.95, then this means there is a very strong negative correlation. So through these two methods we learn the degree of relationship between two variables. Now here if you see in the graph, there could be difference of opinion. If I draw a scatter diagram between x and y, there we can say there is a positive correlation, and strong to what extent is strong. So there could be different opinion for the relationship between x and y, but here we will get a value, then I will get a value and you will get a value, and both we will get the same value, okay. And here also we will get the same graph, but our interpretation for the correlation could be different. But here, our interpretation would be same. That's why we prefer correlation coefficient to study the degree of relationship between two variables. Again, can you see the screen? Okay. Can you see the screen? Simple regression analysis?
Yes, sir.
Okay.
Yes, sir.
Okay. So then if we suppose get a correlation coefficient 0.9895, 0.9, we will say there is a strong positive correlation. But the question is, what about the causality? Okay. Okay. So we want to know if suppose one variable increases by 1 unit, by how much the other variable will change. Okay. So correlation will just tell you the nature and extent of relationship between two variables. Okay. So sometimes we are interested to know the change in a variable due to change in some other variable. So for this we use the regression analysis. Okay. And if we get a regression equation, then we can use that regression equation to predict the future value. So in regression analysis, because it's a bivariate data analysis, so we will discuss first the simple regression analysis. So in a simple regression analysis, there are just two variables. One variable is dependent variable and the other variable is independent variable or explanatory variable. Okay. So the simple regression model, we study the relationship of a dependent variable, which is also called the predict or response variable. It's a single independent variable. So we have just one independent variable, which is called explanatory or predictor variable. So this is a simple regression model. Okay. So y is a dependent variable and x is independent variable. So this is also called two variable linear regression model. So it is linear in variable and also linear in parameters. So these two are the parameters, no? Alpha naught and alpha 1. These two are parameter. And this is the error term, because we believe that if we are not taking this ui, which is the error term, then the relationship will be exact. In mathematics, you have studied exact relationship, but you know, in reality, the relationships are not exact. No? So dependent variable is not affected by only one independent variable. There might be some other independent variable that affect dependent variable. So the effect of all those variables would be captured here, no? Disturbance term, error term. So some variable we have not included in the model because this is a simple regression model. We have included only one, and some variables we don't know. Even if we have more than one explanatory variable or independent variable, that is called multiple regression model. But still there are some variables that affect dependent variables and that are not included in the model because we don't know or we don't have the data of such variables. Now these two are the parameters of the model. These are the population parameters. This is a population regression model. Okay. Now, if we get the data on the population of y and x, then we will get these parameters. But it is very difficult to get the data on population. So then what we have to do? What we have to collect? So we have to collect what? If population data is time consuming and costly, we have to go for
Sample.
Population sample.
Yes, we have to get data for basically sample subset of mute your mic. So sample is a subset of population, and we get sample through some sampling techniques. We have to use some sampling techniques. So there are different sampling techniques. We have probability sampling techniques, we have non-probability sampling techniques, and you have studied all those techniques in your statistics course, so I will not repeat here. So when we get the data for sample, then we have the sample regression model. So through sample, okay, we want to estimate these parameters. So the sample parameter would be the estimator of these population parameter. So we want to get such estimator of the population parameters that are very close to these two, alpha naught and alpha 1. So there is a technique which is known as OLS. Anyone knows what is OLS?
Ordinary least square method.
Yes, ordinary least square. Because get the value of estimated y and this is the value of actual y. We want that our estimated y should be close to the actual y, and this is possible if our values of alpha naught and alpha 1 are close to the actual values of alpha naught and alpha 1. So because the difference between the estimated value and the actual value of dependent variable is the error term, okay, and in the ordinary least square method we minimize the sum of squared error or sum of squared residual, okay, and through this minimization process and we get the estimator for these population parameters. So this is, so alpha naught hat and alpha 1 hat, these are the two estimators of the true population parameter alpha naught and alpha 1, and if we use these two estimated values we will get the estimated value of dependent variable. So through ordinary least square estimators we estimate the value of alpha naught and alpha 1, the true population parameters, and the ordinary least square estimators are blue. What is the meaning of blue? Anyone can say? BLUE. Least square.
कैरेक्टरिस्टिक्स हैं कैरेक्टरिस्टिक्स हैं सर इसकी डाटा की कोफिशिएंट
एस्टिमेटेड
स्केयर की सर ये कैरेक्टरिस्टिक्स हैं.
अरे नहीं आप बहुत आगे चले गए. बेस्ट लीनियर अनबायस्ड एस्टिमेटर्स. सो जो OLS एस्टिमेटर्स हैं दे आर बेस्ट लीनियर अनबायस्ड एस्टिमेटर्स, ओके. तो जो अदर मेथड से जो एस्टिमेटर्स होंगे वो बेस्ट लीनियर अनबायस्ड एस्टिमेटर्स नहीं होते उनमें. दैट्स व्हाई वी यूज OLS एस्टिमेटर, ओके. And then once we get the estimated value, we have to apply this test to confirm the significance of an independent variable. So these are, so our null hypothesis is that alpha 1 equals to 0. If I say alpha 1 equals to 0, this means there is no effect of this independent variable on dependent variable. Okay, and alternative hypothesis is alpha 1 is not equal to 0. So this means there is some effect of x variable on y. So if we accept this null hypothesis through this test, then we will say there is no effect of independent variable on dependent variable. But if we reject null hypothesis, this means there is some effect of independent variable on dependent variable, and looking to the magnitude of that coefficient we can say, and then looking to the sign of that coefficient we can say whether there is a positive effect or negative. So if we reject null hypothesis, then we will say there is statistically significant effect of the independent variable x on dependent variable y. So for this we use t-test, okay, and the level of significance we use 5%, 1%. So if the probability of t statistic is 0.05 or less, then we will reject null hypothesis. Okay, and if it is more than 0.05, if the probability of t statistics is more than 0.05, then we will accept the null hypothesis. Okay, so if the probability is 0.01, so it means again we will reject the null hypothesis and we will say that the coefficient is significant at 1% level. Okay, I will show you some result later on. So because there is only one independent variable, so we have only one parameter, same for attached to independent variable. There is also a parameter which is this one, alpha naught. We can also test the significance of this parameter, okay, whether it is statistically significant or not. So then our null hypothesis will be alpha naught equals to 0 and alpha 1 not equals to 0, and then again we will check the probability of t statistics. Then next, suppose we got this, okay, if you got this equation 20.25 and 0.15, so this shows that when x is 0, the average value of y is 20.25. So 0.15 means there is, because it is a plus 0.15, so this means there is a positive effect of x on y. So when x increases by $1, y will increase by $0.15. So if it is negative, then this means there is a negative effect, and then we have to apply hypothesis test to check the significance of this variable. Okay. Then we have to check how good fit is our model. So we have to check the goodness of fit, and this goodness of fit is measured by R square. Okay, and this is also called the coefficient of determination. And the value of this R square is between 0 to 1. Okay, so if the value is closer to 1, so this means our model is good fit. Suppose if it's 0.98, so it means it is a good fit. Now the value of this R square also shows the proportion or percentage of variation in y, which is explained by independent variable of the model. So if we get R square 0.7, so this means 70% variation in dependent variable y is explained by independent variable x. So if it is 0.8, I just said if the r square is 0.8, this means 80% variation in y is explained by variable x. So we have to achieve, reach a good fit model. Okay. In simple regression analysis, because there is just one independent variable, so value of r square could be low, because the dependent variable depends on many other independent variable, and if we have included only one, so that could not be a good fit model. Okay. So in multivariate data analysis, next class we will discuss how to reach a good fit model by adding other explanatory variable or independent variable in the model. Then if you are using a time series data, then we have to apply the stationarity test, and a variable whose movements, particularly the mean and variance, if they are time invariant, then we will say the variable is stationary, otherwise non-stationary. And there are tests. I will show you those tests and how can we interpret the result. So for a stationarity test, we have decupolar test, augmented decupolar test, Phillips-Perron test. So there are different tests to test the stationarity of the variable. Why we want to test the stationarity of the variable? Because if the variables are non-stationary, so if the series, if the time series data which you are using, it's non-stationary, then if you run a regression model, so then we will get spurious regression. So it means it has no worth. That's why we have to confirm. So if we are using long time series data, then you have to confirm first whether the series is stationary or non-stationary. And some series they are stationary at level, but some series they are stationary at first difference, some series they are stationary at second difference. So we can also know by applying the stationary test whether the series is stationary at level, whether it is stationary at first difference, whether it is stationary at second difference. Then we have if the two, suppose in the simple regression model, the two variables not stationary at level, okay, and but they are both stationary at first difference, then still we can use the regression analysis, and if the linear combination of these two variables is stationary, okay. So for this we use angle Granger Cointegration test, okay. So we run the regression, we get value of residual, and if the residual is stationary at level, then even if the two variables are stationary at the first difference, we will say that there exists a long run relationship between these two variables and the series are co-integrated. Actually these parameters, these are the long run. So if you want to get the short run relationship, then we use error correction model that you will study in your econometrics course. Okay. Then we have bivariate Granger causality analysis. Just like here, if we have this type of model, so from this model it is clear that X is the cause and Y is the effect. So this will cause this, but sometime maybe Y is the cause and X is the effect. So causality, or maybe X is the cause, Y is the effect, and also Y is the cause and X is the effect. So there is a possibility of unidirectional causality, okay, running from X to Y. There is also a possibility of unidirectional causality running from Y to X, or there is a possibility of bidirectional causality when both X and Y are cause to each other. So when we are using a simple regression model, so we are basically assuming when we say Y is dependent variable and X is independent variable, and X is on the right hand side of the equation and Y is on the left hand side of the equation. So this means we are assuming that X is the cause and Y is the effect. So we are assuming that causality is unidirectional from X to Y. But to confirm this, we apply the bivariate Granger causality test. So this is a proper test where I will apply this test on views, and you will see how to interpret the result of this bivariate causality.
ये एक ही टाइम में दोनों चीजें हो सकती है सर?
बिल्कुल, x जो है y को कॉज कर रहा होता है और y जो है वो x को भी कॉज करता है. तो उस सूरत में अगर इस तरह की सिचुएशन हो तो फिर हम सिंगल इक्वेशन मॉडल यूज़ नहीं करते हैं, फिर हम साइमल्टेनियस इक्वेशन मॉडल यूज़ करते हैं. देन वी हैव टू यूज़ साइमल्टेनियस इक्वेशन मॉडल. तो एक इक्वेशन में जो है वो x जो है वो इंडिपेंडेंट वेरिएबल होगा और y जो है डिपेंडेंट वेरिएबल. दूसरी इक्वेशन में जो है x जो है वो डिपेंडेंट वेरिएबल बन जाएगा और y जो है वो इंडिपेंडेंट वेरिएबल बन जाएगा. तो इस तरह हमारे पास टू वेरिएबल है ना साइमल्टेनियस इक्वेशन मॉडल बन जाएगा. तो इसीलिए हम जो है ना साइमल्टेनियस इक्वेशन मॉडल यूज़ करते हैं अगर बाई डायरेक्शनल कॉजलिटी हो, दोनों वेरिएबल एक दूसरे को कॉज कर रहे हैं. देन एज आई सेड वी हैव टू यूज ग्रेंगर कोइंटीग्रेशन टेस्ट. तो उसमें अभी मैंने डिस्कस किया है व्हेन द वेरिएबल्स आर स्टेशनरी एट फर्स्ट डिफरेंस. तो हम उसको कहते हैं कि ये I1 है, इंटीग्रेटेड ऑफ ऑर्डर 1. सो इस किस्म के वेरिएबल टाइप ऑफ वेरिएबल for this type of variable we have to apply the Granger Cointegration test. So we run the model, the level, and we get the value of the residual, and then we check the stationarity of the residual. If the residual is stationary at the level, now look at variables are stationary at first difference, but the residual from the regression model is stationary at the level. Then we will say that there is a co-integration between these two variables and there exists a long run relationship. So